Okay, so in this section we're going to talk about mutually exclusive and non-mutually exclusive events. So as you can tell by what I've drawn here, mutually exclusive things are something that will not overlap at all, versus if they're not mutually exclusive from each other, then they do have something that overlaps. Okay, so here's the first question. What's the probability of drawing an ace or a face card from the deck? So do you know what aces are? These are the aces, right? The face cards are these. So would you say that they overlap each other or anything? No. So is it mutually exclusive? Yes, they're mutually exclusive from each other. So when I look at this deck, how many opportunities do I have to draw an ace? How many of those are there? 4. Or, so I'm going to add, how many opportunities was there for me to draw a face card? 12. That makes how many favorable cards? 16 favorable cards out of, what's the number of total cards, guys? 52. Okay, number 2. What's the probability of drawing a heart? So these are the hearts, right? Those are all the hearts. Or a face card. So then those are all the face cards. Are they mutually exclusive from each other? A heart, hearts, and face cards. Are they exclusive? No. Why aren't they exclusive? Because these 3 cards are hearts and face cards, right? They belong to both groups. So they are what I would say the overlap. Okay, so how many opportunities do you have to get a heart card? How many hearts are in this deck? Do you remember? How many of these?
Like just hearts?
Hearts. 13 hearts. Or how many face cards are there? How many face cards are there? Overall, how many face cards? 12. But what happened? We counted that in both groups, and that in both groups, and that in both groups. So we have to subtract that because we can't count them twice. So how many cards are favorable? 22 out of a probability, so out of 52. Okay, I guess if you're looking at it and you say all of these hearts, so if I cover up all the hearts, so there was 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, right? Okay, if you roll a sum greater than 8 or a multiple of 5 when rolling 2 dice, you get a bonus. So, do you remember we did something like this when you were rolling 2 dice? Do you remember what I did? I did a chart. How many different scenarios do you have when you roll 2 dice? How many different scenarios do you have if you roll 2 dice? There's 36 different things that could happen, right? You could roll a 1 and a 2, or you could have rolled a 2 and a 1. You could have rolled a 5 and a 5, right? Like there's a bunch of different scenarios you could have done. Okay. Do you want to just list all the sums? So if you roll a 1 and a 1, those dice would give you a sum of 2. A 2 and a 1. So 2, 3, 4, 5, 6, 7. So then this row would be 3, 4, 5, 6, 7, 8. Can you continue and fill out the whole thing? So the largest sum you can ever get is 12, right? Using a 6 and a 6. Okay, so those are the 36 scenarios. Okay, ready? Here's the question. If you roll a sum that's greater than 8. Okay, so what am I going to do here? What are my options? How do I get a sum greater than 8? I could have done any of those scenarios, right? That would be good. Greater than 8. Or I'm trying to get a sum that is a multiple of 5. Do you know what a multiple of 5 is? What are your options? 5 or 10, right? The next one would be 15, but we don't have that on a dice, right? So multiples of 5 and 10, but do I count them twice? No. So how many are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 out of 36. Okay, if I was to ask you, are those mutually exclusive? Was that question? No. No, and the reason is 10 belong to both groups, right? So we had to account for that 10. We didn't want to count it twice, right? Okay, we're going back to Venn diagrams now. We did so good at this in the logic unit. Okay, so here's what happened. A newspaper did a survey and they were doing people's eating habits. So we're going to do a Venn diagram. And the scenarios are people who skip breakfast and people who skip lunch. So they skip their breakfast or they skip their lunch. So people in the overlap skip both meals, right? What would be outside of those bubbles? Inside the bubble is people who skip breakfast, skip lunch. What would I write out here? They eat. People who eat, right? They don't skip. People inside the bubble skip, so then people outside the bubble would not be skipping, right? Okay. What should everything add up to be? Everything should add up to be 100. Okay, so read this and this and this. One of those three statements we can place. Out of those three statements, do you know which one you could for sure put somewhere? What, the bottom one, is that what you said? Yeah. 22 eat both. So we could put 22% on the outside of the bubbles. Okay. How much percent should we have in our bubbles? Anywhere in our bubbles, what is our percentage left? 100 minus 22 is 78, you said? We should have 78%. Okay, so let's add these up. So 62 plus 24, that makes 86%. That's too much to fit in my bubbles. I only wanted 78 and I got 86. So therefore, how much has to be in the overlap? Remember doing something like this? Mm-hmm. Overlap will be 86 minus 78, 8%. So 8% of the people skip both meals. Man, they must be pretty hungry by the end of the day. Hangry. Okay, now, how many do I have to put here? Because how many percent do I need inside the breakfast bubble altogether? I need 62% in the bubble. So what is this? I already have 8 inside the bubble. So that's what, 54? So do you see in the whole breakfast bubble there is 62? And how much do I need just there? You said 16? Okay. Are these mutually exclusive? Nope. Because there was an overlap. Determine that the probability that a randomly selected student skips breakfast but not lunch. What's the percent on that one? They skipped breakfast but not lunch. So they're only skipping breakfast. What's that percent? Which one is just skipping breakfast? 54. And it's a probability, so we can say that as a percent. 54%. Determine the probability that a randomly selected student skips at least a meal. So what would that be? If you're skipping at least a meal, it could be anyone in your bubbles. What was this whole bubble worth? 78%. Anyone inside a bubble is skipping something, right? So then I add that all up. My mother buys a new washer dryer for $2,500 with a 1-year warranty. She can buy a 3-year extended warranty for $450. She researches the repair stats for it, the set, and finds this out. So the probability of everything, and then we're going to figure out if she should buy the extended warranty. Okay, so let's get these percents. Washer, dryer. So the percent of fixing the washer, percent to fix the dryer. What would I put on the outside of my bubbles? If inside the bubbles is fixing the washer, fixing the dryer, what's on the outside of my bubbles? Not fixing. You don't have any fixes. If you wanted to fix the washer and the dryer, that's in the overlap, yeah. So inside the bubbles, you're fixing something. Outside the bubbles, you don't have any fixes. Okay. Look at those 3 statements. One of them you can put somewhere. The 3%, it goes into the both. So that's the first thing you can do. 3% can go into the both. So inside the washer bubble, I need 22%. So what do you put right there? 19. Inside the whole dryer bubble, I need 13, so this would be a 10. So what's the percent of people who don't have to fix anything? What are you going to do there? 19 plus 3 plus 10 makes what? 32?
Yeah.
So how much percent of people are just not fixing anything? 100 minus 32? So 68% don't have to fix anything. This is within a year. Okay, ready? To fix the washer, okay, you have a 19% chance of having to fix just your washing machine. Average cost is $400. So we're going to times this by 0.19. There's a 19% chance. What is your expected value? No, I don't want to do that actually. No, sorry. Let's just say this. There's a 19% chance that you're going to have to pay $400. How about we just make that statement? There's a 19% chance you're going to have to pay $400. Fixing the dryer, there's a 10% chance that you're going to have to pay $300. Fixing both, there's a 3% chance that you're going to have to pay $700. And there's a 68% chance that you'll have to pay nothing because you have no repairs. That's how I'm going to analyze that. Okay, so what do you want to do? Do you recommend that she buys the 3-year warranty? It costs $450 to buy a 3-year warranty. Would you say yes or no? No, I would say no. Why? This is the only situation that would cost you more than $450. That's the only bad situation that costs you more than $450. And what's the probability of that? 3%. Are you going to take that risk? Probably. If this happens, $400 is still cheaper than paying the warranty. If this happens, that's still cheaper than the warranty, right? So this is the only situation that's more than the warranty would cost you, and there's a 3% chance, low, and really $700 is not that much more than $450 anyway, right? I wouldn't recommend it, but they're going to sucker you into it anyway somehow. Okay, a car manufacturer keeps a database of cars that are available for sale in Western Canada. For Model A, the database reports 43% have heated leather seats, 36% sunroof, 49 have neither. So here's my situation. Heated seats, sunroof. Are the bubbles outside the bubbles are not having anything like that? Okay, so I gave you 3 pieces of data, and guess what? You can put one of them somewhere. Which one of those statements could fit in somewhere? 49% have neither. So that's out of the bubbles. So what do we all need in our bubbles? We need to have 51% in our bubbles, okay? If 49 is out of the bubble, we need 51 in the bubble. Okay, so let's add these up. So 43 plus 36 is 79. That is way too much to fit in the bubble. So now what? Subtract 51 is the amount you're going to have to overlap. So 28% would be in the overlap. So the heated seats, I need 43, but I already got 28. What's that? Left. 15. In the sunroof, I need 36, but I have 28, so 8 is left. Okay, obviously if you added all 4 of those numbers together, they would have 100% as a total, right? Determine the probability of a Model A car at a dealership having both seats and sunroof. So what would your answer be to this specific question? What's our final answer here? The probability of having both is, where do you find that on this diagram? Having both is 28% of the cars would end up having both.